My name is Maria Contopodi and I will be talking about check sheets, what they are, when to use them and why this might be a good idea, a story about how a check sheet fixed my pizza, and how to make one with what we have at hand. According to PMBOK, a check sheet is a quality tool per knowledge area, a tally sheet that can be used as a checklist when gathering data per form, and a tally sheet to organize facts for effective collection of useful data about a potential problem per function. In Six Sigma, it's considered a simple data collection device that captures critical information manually when and where it happens. The check sheet is one of the 7 basic tools of quality control made popular by Dr. Kaori Ishikawa under the name Elementary Statistical Method. Dr. Ishikawa believed that as much as 95% of all the quality problems within a company can be solved by means of these 7 tools, to which the check sheets were the shortest backbone for data input. So when do we use a check sheet and what are the benefits we might get from it? Dr. Ishikawa places a scratch paper as equal among graphs and tabulations. Well, his reasoning is a good place to start. Dr. Ishikawa was a Japanese modernist, and as such, he believed in the form follows function before it was go. He identified 5 types of check sheets. The first type is used to check the shape of the probability distribution in the process, or how likely are things to be that way. The second, the third, and the fourth is to quantify defects by type, as of what kinds of defects we have, by location, as of where exactly we're having it, and by cause, as are we having it by human or machine error. The fifth serves to keep track of the completion of steps in a multi-step procedure. So, 5 discrete forms of check sheets are thus defined by these functions. The following check sheet, which shows an account by range of length of logs in a sample of 95 trees, is a good example of Ishikawa's first type. A good example of the second type is the sheet noting the failures of rendered mechanical equipment over the period of 3 days. An example of the second type is the shaft production defects concentration diagram depicting areas where the defects were found on a sample during testing. The machine operation failures over the course of 2 shifts and between 2 operators on the right offers a good example of the third type. And last but not least, an example of tracking failures in the multi-step process is the multi-sectional tracking sheet used for quality control and compliance for export. So let's take a closer look at data. In a project, there are 3 types of data we can collect: attribute data, variable data, and locational data. An attribute is not numerically measured. It is either there or it is not, and we can only count the absence or presence of a characteristic or a defect. To count, we need to rely on occurrence of discrete events like voting, true or false, and accepted or rejected statements. Variable data is based on numerical measurements of a key quality characteristic produced by the process. To collect a measurement, we would have to employ an instrument or device. The following table offers a comparative overview of the 2 types of data. By comparison, measured data is regarded as being better than counted data. It is more precise and contains more information. Collecting measured data, however, is often difficult or expensive, so counted data must be used instead. In certain cases also, data will only occur as counted data. And for information which can be obtained as either or, variable data is generally preferable. Location of data, the last of our types, is neither numerical nor attribute. It is a specific type of data, simply stating where. Charts that utilize locational data are simple markings on diagrams or pictures reporting location of occurrence. In a project, therefore, we would use a check sheet if we need to gather data about the attributes of the project, or if we need to inspect and identify different defects, or if we need to tally project metrics to produce some meaningful output for other analytical tools, such as the Pareto analysis. The check sheet is literally a Swiss Army knife to quick and easy quantify the situation. We can analyze the repetition of data in the same or similar scenarios, we can collect data from a production process or a repetitive operative application process, collect data on the frequency of patterns of events, problems, defects, defect location, defect causes, or similar issues. We can use it also to analyze existing data in order to make sense of an existing problem. Condition, though, to maintain quality in the process is data be observed and collected repeatedly, either by the same person or at the same location. The most common types of check sheets we would use in a project we can identify as the following 5 basic ones. It's the failure check sheets, the traveler check sheets, visual check sheets or measles charts, tally charts, and checklists. The failure check sheets are used for collecting information on one specific product, process, or service. They are used when collecting process failure information classified per more than one variables, as locate failure in the process as opposed to the finished product. Generally, they can also be used to keep track of the proper completion of steps in a multi-level procedure. The second type is known as traveler check sheets. These are live documents that remain attached to the product, the process, or the service at all times, beginning to end. They're used when collecting process lead times in order to build time or follow cost developed over time. Visual check sheets are used when collecting location and occurrence data of product defects. Defect sheets or measles sheets, as we also know them, may vary in the depth of analysis of the issue mapped, the lowest of levels being where markings are simply pointing to the area of occurrence of defect. A tally chart will collect and classify the occurrence of predefined events or failures over time. By tracking traits within time frame, it offers an overview of the location and density of events as well as an input to statistical analysis. A checklist may be the most common of them all. It's a document that contains data collected from a list of items to be verified or steps to be taken before other things can happen. Checklists are essential in inspections and audits when we need to verify compliance with requirements, standards, and codes, or anywhere we need to ensure that proper procedures are being followed. A really good example on how we can use check sheets to approach and resolve a customer-related issue is the story about this pizza place somewhere. In this story, a pizza place conducts a customer satisfaction survey and a check sheet is employed to analyze, that is to tally and sort the following data that they have collected. After conducting the data collection, the team applied Pareto principles to identify the main errors and put together an action plan to eliminate once and for all the problems raised in the process. Let's see now how we can create a tailored check sheet to fit a hypothetical scenario. In our Team Z scenario, we need to improve the safety initiatives for a public event, and this involves several steps taken for temporary provisions that will respond to specific user requirements. The last one in the list, which refers to signage, I will use here to demonstrate. In this scenario, a number of signs is ordered, delivered, and installed. This means primarily location and attribute data will have to be collected and put against requirements. These requirements are currently existing in the forms of a Measles diagram, which is a site plan, the tally sheet, the signage schedule, and the checklist, which is the ADA and OSHA compliant. The creation of a check sheet would follow 3 steps. Step 1, we apply the 5W rule of thumb to define exactly what needs to be done and what sheet we will create to respond to what. Step 2, we build and test it on a small amount of data. And step 3, we train the people that will handle the check sheet appropriately out in the field. This 5W rule of thumb will demand that we have explicit answers as of who, where, what, when, why, and how all of this is going to happen. The result scenario gives us an excellent overview of what we need to have at hand to perform the tasks described, as well as the tool needed or needed to be built. This is an example of a fully 5W compliant check sheet in that sense. The general guidelines for creating the check sheet is to be precise, specific, and keep it simple. We start with a list of the issues we are tracking, leaving room to add ones that might come up along the way. We add columns to it as needed, define the time frame in which the data will be collected, encouraging the recording of contextual data as well. When we are done, we test and troubleshoot. Applying the general outlines to my scenario, I conclude what I need to check is quality of delivered items, quality of installation process, and what failures to look for, as well as when and how many times I need to do it. Furthermore, I know that I need to test it in an area with a certain variety of items that I can troubleshoot. In my scenario, collected data will be put against another set of data for conformity, so it only makes sense here to use this as a base instead of starting from scratch. The first stage of quality check is at the acceptance of the communication devices before the field installation begins. At this stage, we have only 3 conditions to check, and that is accepted, defective, and missing. And each item must be verified individually. Therefore, it made sense that we create a check sheet based on the original schedule by inserting additional check fields appropriately. Testing with the sample data did not reveal a severe flaw in this design. Creating a check sheet for the code conformity with installation process, however, required a completely different approach. At this point, we followed the opposite procedure of actually taking a sample area and troubleshooting to create the check sheet. The signage schedule showed that area 2 was indeed a good case to work on. In the original site plan, each sign is marked with a different shape, which represents the approved type of sign. A glossary of colors now introduced to color code each sign's current condition. So we have red for missing, yellow for defective, blue for improperly mounted, and green for additional sign needed. So, how do we transition from location to count data to make it really usable? As a first step, we extract and sort the sign-related data we just collected from the diagram. That way, we just managed to transform location to attribute data. Sorting by attribute, color, and feeding the results in a matrix transforms the location data we just collected to numerical count data, which is something that we can definitely use more efficiently to actually finish this job. The completed form of this check sheet could be looking a bit like this. The last step to be taken, when we feel confident that the tool is actually working, is to train the people that will use it and troubleshoot with them further while at it.